Hello and welcome to another tutorial, this one on quadratic sequences. And today we're going to be answering what is a quadratic sequence and how do you generate a quadratic sequence by using its nth term. So first off, we're looking at this sequence here. Now a quadratic sequence is a sequence where the second difference is constant. So if we compare it to a linear sequence, like 6, 8, 10, you can see there that the difference between these is constant. It doesn't change. It's always +2. Now when we compare it to 1, 4, 9, 16 and 25, the first difference is changing as we go along. So remember I said a quadratic sequence is one where the second difference, so that 3, 5, 7, 9, you should notice, has a constant difference between them of +2. Yep, so on a linear you'll get straight away a constant difference, but in a quadratic it takes a second level of comparison to get that +2. Also, from looking at quadratic expressions, you would know that a quadratic sequence will also have an n squared. The highest power of n you'll get is n squared. So let's start looking at how you generate it. So first of all, the sequence that we saw first, 1, 4, 9, 16 and 25, is actually n squared. N being the position or the place in that sequence. So my fourth number is going to be 4 squared, which is 16. So I'm looking at n squared plus 5. So that's n squared. And so n squared plus 5 is just simply adding 5 to each. So plus 5, 6, plus 5 is 9, plus 5 is 14, plus 5 is 21. And what you'll notice, because you're adding 5 each time, the difference between it doesn't actually change. So the difference between 1 and 4 is 3, and it's the same difference between 6 and 9 there. So that doesn't change, it's just the values that change because you've increased it, each number by 5. Okay, just to clarify, you can see that as well. Difference between 9 and 14 is 5, and the difference between 4 and 9 is 5 as well. So it really doesn't change the difference, but it does change the values by increasing them by 5. Another example would be 2n squared. So 2n squared, we can start off with our n squared already. So what I'm showing you is sort of a table form. You could have these values in a table, and so you'd go n is equal to that, 1, 2, 3, 4, 5, n squared, my first 5 square numbers, and so 2n squared is going to be 2 times everything in n squared row. So 2 times 1 is 2, 2 times 4 is 8, 2 times 9, 18, 2 times 16, 32, 2 times 25 is 50. Okay, and when you compare 2n squared to n squared, you'll notice that the difference actually doubles. So you are multiplying. When you do that, you do increase the difference as well. So that becomes 6, whereas it used to be 3, and there it becomes 10, where it used to be 5. So just to recap, you just timesing everything in the n squared row by 2 and you'll get these, but you can also check because your gaps will double as well. If I show you, let's just get rid of this square or rectangle even. Now if you've got 5n squared, start off the same way with our n, then our n squared column, our row. Multiply by 5, you'll get 5, 20, 45, 5 times 16, 5 6 is 30, so you get 80. 5 times 25 is 125. And you'll notice as well the difference between them. So that was once plus 3 has now become plus 15. Okay. So what about something where you not only add something and times it by 2, here you are multiplying and adding. So 2 times n squared plus 6, starting the same way with a table, n squared is now equal to 1, 4, 9, 16, 25, doesn't change. And so 2n squared is now 2 times that, which we've seen, so 2, 8, 18, 32, and then 2n squared plus 6 would be everything in this row plus 6, and so 2 plus 6, 8, 8 plus 6, 14, 18 plus 6 is 24, 32 plus 6 is 38. I won't compare the differences there, but you can see then that's what happens. So I'm going n squared, then doubling it, then adding 6. So if you're sort of not fairly certain about substitution, this is probably the best way to go. You do it in steps as you go along. Okay, now 2n squared plus 3n plus 3. If we do it the table way, still again, we start with n squared, then we go 2n squared, and so 2n squared is just double whatever's in the n squared row, so 2, 8, 18 like we've seen before, plus 3n. So I'm going to break it up and I'm going to make a 3n row, which is 3 times n, my position, or n, the number in the sequence, the place in the sequence. And so it's 3 times 1 is 3, 3 times 2, 6, 3 times 3, 9, 3 times 4, 12, 3 times 5, 15. And then I need my 3, which I'm going to add. So I'm just going to put it on the end there. And so that would just be 3, 3, 3, 3, 3, because it's constant. At the end, because I want 2n squared plus 3n plus 3, I will be adding my 2n squared row to my 3n, and then adding 3 at the end as well. And so your final sequence there becomes 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 6 is 14, 14 plus 3, 17, 18 plus 9 is 27, 27 plus 3 is 30, 32 plus 12 is 44, 44 plus 3 is 47, 50 plus 15 is 65, 65 plus 3 is 68. And so that's 8, 17, 30, 47, 6, and 8. 68, sorry. 47 and 68. Right. Lastly, what would it look like, or how could you do it without having to draw that long table? You must be fairly confident in your substitution and understand BidMass. And so you know the first thing you're going to do is your indices, which is squared. Then you're going to multiply 4 and the 5 ends, and then you add everything in the end. So essentially what we're doing with the table, but we're going to do it all in one. So 4n squared plus 5n plus 3. I start off with n. 4n squared is then going to be 1 squared is 1 times 4 plus 5 times 1 is 5 plus 3 times 1 is 3, and that is equal to 9 plus 3, which is 12. So I'm writing my working out, but essentially this is the sort of working that you would do in your head. So you then do, when n is 2, 2 squared is 4, 4 times 4 is 16. Then you do 5 times 2 is 10, and then add your 3. So 16 plus 10, 26 plus 3 is 29. Third term, 3 squared is 9, 4 nines are 36, 5 times 3 is 15, and then you add your 3. So 15 plus 3 is 18, 18 plus 36 is 54. I'm just going to do one more term to make it 4 terms. So 4 squared is 16, 16 times 4 is 64, 5 times 4 is 20, and then you're adding your 3. So 64 plus 20, 84, 84 plus 3, 87. So the first 4 terms of the sequence 4n squared plus 5n plus 3 is going to be 12, then 29, then 54, and 87. And that is it. Thank you for listening.